Okay, morning everyone. Thanks for coming along. Looks like we haven't lost too many, if any at all. So I'm going to try cover Windows Server 2012 Hyper-V in an hour and 3/4. I was stressing last night because I, at that time, had an hour and a quarter. And usually the feedback I get from people when I have presented it in a day is that they would rather it be covered in 2 days. So luckily, we did the storage bit that I'd normally include yesterday. And some of the other networking stuff that I would normally cover, John is actually going to be covering in a little while. So, briefly, I'm technical sales lead at Micro Warehouse. I'm an MVP. I blog on aidanfin.com, and as of last night, I started blogging on petri.co.il, so the Petri knowledge base, and I tweet is @Joe_Elway. And this is what we are going to attempt to cover today. However, this is just a tiny, tiny subset of the features in Windows Server 2012 Hyper-V. And yesterday, Dave was saying that probably half the features of Windows Server 2012 were in Hyper-V. Dave got it way wrong. Absolutely, the vast majority of the new stuff is in Hyper-V or is directly because of Hyper-V. So, first we're going to start talking about converged fabrics or converged networks. Fabric is basically a cloud computing term for a network. And there is a learning curve to what I'm about to present you. When I teach this, I do warn people they are not going to grasp it the first time. This is the sort of thing that you have to come back over. I've blogged about this extensively. There is 100 pages in the Hyper-V book on this topic. And really, to be quite honest, there's two elements to this. A, to really learn it, you have to do it. It's no good listening to someone talk about it or look at slides or videos or anything. You really do have to do it. And secondly, there is no one correct design. There are wrong designs, but there's no one right design. In other words, when I design the networking for Hyper-V for customer A, it might be completely different to how customer B might do it. So I've recently saw how Didier Van Hoy has posted how he's going to do it, and it's very different to how I would do it, but it's right for him. It comes down to what type of storage you want to do, how you want to optimize your storage, what offloads do you want to turn on in your hardware for optimizing virtual machines, for normal host traffic. There's just so many different things. Oh, and how much money you've got, because obviously that always has an impact. Okay, so the first thing I'm going to talk about is NIC teaming. Dave mentioned yesterday NIC teaming is in Windows Server 2012. This is the first time Microsoft has given us NIC teaming. We've always had NIC teaming from third parties. That is not supported by Microsoft, ever. Never has been. If you've been using HP NIC teaming, Dell NIC teaming, Intel NIC teaming, Broadcom NIC teaming, you had a network problem and you went to Microsoft, Microsoft support services were quite entitled, and it was publicly posted, has been for donkey's years, that they could turn around and say, please reproduce that networking problem without NIC teaming. Because what you have effectively done by using that third-party NIC teaming is ripped out the guts of Windows networking, put in the third-party NIC teaming, shoved in as much back as possible of the Microsoft networking with a few bits left over, and it was held together with baling twine and duct tape. That's pretty much what third-party NIC teaming is. And if you, for example, there's one particular server manufacturer's NIC teaming that if you didn't follow their documentation, you could actually create insecure networking where you could hop VLANs on that particular server. Yeah, which would be pretty bad. It actually introduced its own security flaws, which you wouldn't have with just the basic Microsoft product. So now we've completely supported NIC teaming in Windows Server. It's fantastic, up to 32 NICs, all operating at the same speed from multiple manufacturers. So if you're in a genuine mission critical environment, planes will fall out of the sky. Not that Honest Bob's car sales will, have a brief glitch. But a genuine mission critical environment, Microsoft would even encourage you to have different manufacturer NICs in the NIC team, in your host. So that's genuine mission critical. Not that I'd like it to be operational as much as possible and I have 10 euros over my budget. That's not mission critical. The teams are configurable and there's multiple different configurations. Most people don't know this, but there are configurations to NIC teaming. Most people just fire up a NIC team, bind two NICs together, pull out a network cable and hope for the best. When you start getting into virtualization, start pushing workloads through these NIC teams, you start to notice that there are different configurations. So for example, in the HP network configuration utility, there's a drop-down box that gives you a whole bazillion different list of options for configuring that NIC team. And we have something similar in the Microsoft world. We can configure it using PowerShell, and there's a GUI tool as well called lbfoadmin.exe. And you can also get to that using Server Manager. There's some terminology. So we have the NIC team, which binds together, so LBFO, load balancing and failover, which basically gives you NIC aggregation. It aggregates multiple NICs between 2 and 32. These are referred to either as team members or network adapters. And from this, we can have one or more team interfaces. So these are the things that you configure your TCP/IP in. So these guys just become hardware, and these are the things you configure your TCP/IP in your various protocols. You'll have at least one. In the Hyper-V world, that is the supported configuration, one of these, the default one. You don't use any of the others. If I was creating a web server that was going to be on multiple VLANs, for example, I would deliberately maybe create multiples of these so they have different VLAN bindings or different IP addresses or something like that. But if I'm attaching a virtual switch or a virtual network, if you want to use the old terminology, to this NIC team, I would bind it to a single one of these, and there would be no VLAN binding on that. If you want to know a lot more about NIC teaming, again, there is the book, but it's also covered on my blog in extensive detail. And actually one of the better pieces of Microsoft documentation is their NIC teaming document, which you can download. There is a white paper. So team connection modes, we have switch independent teaming. Ooh, interesting font size. So switch independent is where the NIC team operates completely independent of the switches. So there's no configuration on the switches to make this work. Those could be different brands of switches. It could be a single switch. And our NIC team, ideally we want to connect each of our NICs in our NIC team to a different switch. And then we have switch dependent mode, and this is where we have actually two sub options. There's static teaming, which is where each of the switches in our configuration, and this could be a switch stack, that's why you're seeing a single logical device here. So this could be 3 switches that are stacked together. In static teaming, we would have to configure each port on the switch to recognize that it's connected to the same team. And that's a very inflexible design, because if we had to change the networking of the host, we then have to remember to change the static teaming on the switch or the switch stack. And then we've LACP, which is more dynamic. Again, we do have to enable LACP teaming on the switches, but after that point, if we configure the switch team to use LACP teaming, it will actually send a packet out to the switches to say, hey, these ports are actually all working together as a team, and then the switch will actually start using those ports as a team. So those are the connection modes. We have load distribution modes. Common misunderstanding of NIC teaming is that people think that if this server here is sending packets to another specific server, they think the packets are going to go across all the NICs in the NIC team. That's not what happens. There is aggregation of NICs, so multiple streams can go across multiple NICs, but a single stream of communications actually goes over a single physical NIC. So in the Hyper-V world, we see people saying, I've created a NIC team for live migration, and for some reason, only one NIC is being used. Well, yes, because there is one stream of bandwidth between the server, the source host, and the destination host. If there were multiple destination hosts that virtual machines were live migrating to, then maybe multiple NICs in the NIC team would actually be used. We have 2 basic types of load distribution mode. We have address hash. To keep this simple, and it's not specifically true, but to keep it simple, address hash is for non-Hyper-V workloads. That's for your physical servers, like a file server or something like that, where you want to team its NICs. And then we have Hyper-V port. The name kind of gives it away. That's the one that you should use when you have Hyper-V virtual machine traffic going through that NIC team. Again, I'm barely touching on this stuff today because I would normally, with the NIC teaming stuff, take about an hour to go through it. And we have a lot to cover today. You'll have this slide. It basically gives you a summary of all the different configurations. You're getting the slides, so Dave is actually collecting them. But typically what I would be trying to do is switch independent Hyper-V port if I was creating a NIC team for my virtual switch, because that gives me the best throughput. And another benefit is if I'm using a hardware offload, it will actually statically send the traffic that's incoming to a virtual machine through the same NIC every time. Unless that NIC goes offline, then the traffic will dynamically go through another NIC. Okay, just to show you it, I'm not going to actually do too much here, but I am going to show you it. So lbfo admin.exe. This is, yeah. Okay, I will reconnect to my host. I wish they would fix this, that if you change screen resolution. So this is lbfoadmin.exe. And here you can see I actually have a team configured. That's my team right there. But what I can do is I can come down here, select a pair of available NICs, and I could, not that I would ever team those NICs, and I go add to new team. And what it gives me then is this dialog here, where I'd name my team. If I expand additional properties, this is where I configure the various settings of the NIC team. So my teaming mode, switch independent or switch dependent, and my load balancing mode, so Hyper-V port or address hashing. And if I do have multiple team interfaces, which I should not have if this team is going to be used for a virtual switch, then this is where they are. And that team interface is that thing there. And that is where I would then configure my protocols. I wouldn't configure the protocols on the physical NICs after that point. So that is a very brief intro to NIC teaming. And you wouldn't believe how many people cheered when Microsoft announced they were including that in Server 2012, because it was a big, big ask. Okay, now we're starting to delve into the nosebleed section. QoS is now in Windows Server 2012. We've always had well, not always, but for the last few versions, we've actually had a limited version of QoS, where we could deploy out policies using group policy and have them applied by the physical network. So group policy would just tell networking, hey, we want you to tag the traffic. So the physical network administrators could configure the switches and then use those tags to apply QoS rules to the traffic. Traffic shaping, basically saying things like we're going to limit the amount of bandwidth that something can use, or guaranteeing something a certain amount of bandwidth. So if a certain service, a certain protocol, or a certain network connection looks for X amount of bits per second, it gets that minimum amount. And if it needs more, it can burst. And if there's contention, it's always guaranteed that minimum amount. And that's what QoS is all about. Now we can do this for outbound traffic in Windows Server 2012. And this is very useful in the Hyper-V world. We have three types of QoS we can actually apply. We can apply QoS rules to virtual network cards. These are the things the virtual machines are communicating with. And actually, there's more than that now, which I'll get to. But if I want, I can say this particular virtual network card is guaranteed 20% of bandwidth, or X bits per second. And that's useful if we're sending traffic through a virtual switch. So we're using virtual NICs. We have another one, this third one here, where my traffic is not going through a virtual switch. It's not sourced by a virtual NIC. It's actually physical NIC traffic, so file server, something like that. If I have basic, actually, no, I'll skip that. I'll go here. So this is the one I'm talking about. So I've got my traffic. It's physical server traffic, and it's going through a physical NIC. If I don't have a NIC that's capable of doing something called data center bridging, data center bridging is where we apply QoS rules on NIC and on the switches between the source and the destination. So if we don't have a capable NIC for that, then we can use the OS package scheduler. Basically, we create QoS rules that say guarantee X amount of bits per second or a certain weight of bandwidth for this protocol. So we can say my backup protocol, my RDP protocol, my cluster heartbeat protocol we can start guaranteeing it on a per protocol basis. So whereas this one was doing it on virtual NIC, this one will be doing it on a protocol basis. If I have DCB networking, that's always more efficient because we're doing it at the hardware layer rather than in the software layer. And finally, we have the third one. Yesterday we talked about RDMA, Remote Direct Memory Access. This is where we can have file server traffic that completely bypasses the Windows networking stack. If it's bypassing the networking stack, we can't do QoS using the OS Network Packet Scheduler because it never sees that traffic. So in that case, we must use NICs that support data center bridging because we have to apply the QoS rules at the hardware layer. And this is for outbound traffic, it's not for inbound traffic. And we can continue to tag traffic as well on the physical network if we want. So the network administrator has...
QoS for the tag traffic specifically, you're not talking about ports and so forth.
We can continue to do what we've always done in the past. So we can tag the traffic using group policy. We can actually do it using PowerShell on the host itself and say when the network sees this particular traffic, you know, the network administrator can do his own shaping.
There's no voice that you'll have just as primary.
Yeah.
Are you recommending then that file servers should be physical hosts rather than...
No, I'm not.
You just keep mentioning the fact that you're...
It's just an example.
Right.
You're reading too much into it. The certain file server I would keep as physical, which is my scale-out file server, where I'm storing my Hyper-V virtual machines. My end-user file server is probably a virtual machine. Okay. How many NICs in a Hyper-V clustered host?
Which OS?
Well, it depends. But 6 is not a bad answer. If I'm doing iSCSI, minimum of 6. If I'm not doing iSCSI, if I'm doing SAS or Fibre Channel, I would have needed 4. If I wanted to do NIC teaming, well, that's a lot of NICs. What if I want a dedicated backup network? That's another NIC team. That's a lot of NICs. And you get into the cabling business rather than the server business. And I hate cabling. I'm actually brutal at cabling. We once actually hired a contractor to come in and do the cabling for me. Actually clean it up because I was brutal at it. Why do we have all these NICs? This is physical Hyper-V hosts. Think of them even as VMware hosts. Why do we have all these NICs? Correct, and why did we do that? Correct, Dave. QoS. That's why we did it. We didn't have QoS in previous versions of Windows Server. My cluster heartbeat needed a guaranteed 100 meg of network. Now we were always putting in a gig network because that's typically what we get in our servers or our quad port cards. My live migration need a guaranteed minimum of 1 gig. Bigger my host though is, or if I have bigger hosts, I want 10 gig networking because I have a host with 256 gig of RAM. Think how long it's going to take to synchronize 250 something gig of RAM across a 1 gig network if I need to do maintenance on that host as quickly as possible. So 10 gig networking for live migration is fantastic. But 10 gig networking ain't cheap. It's getting cheaper. We just saw an SME 10 gig switch come in at about $1,200 in the States. My virtual machines, I'd have a dedicated NIC or NIC team there. Management OS, dedicated NIC or NIC team there. Backup the same, trying to isolate it so it wouldn't impact the services on the others. So we physically isolated them for QoS. But now I can start doing QoS within the operating system. So potentially, I can have fewer NICs. I could use, we'll call it a pipe of that's made up of fewer NICs, but with the necessary total bandwidth. And I can start doing traffic shaping using QoS. Here's an example. Here's your typical rack server with 4 1 gig NICs. And it's going to be a clustered host that's attached to SAS or Fibre Channel storage. And you got something a little different in here. In the past in Hyper-V, we had the our possibility to share the virtual network's physical NIC with the parent partition or the management OS. I typically didn't like that, but what it actually did was it created a virtual NIC in the host for the host. People didn't realize that, but that's what it was doing. And now we can deliberately do that, but we can create lots of them. So these virtual NICs connect to the switch, the virtual switch, the same way as the virtual machine's virtual NICs connect to the virtual switch. It's a bit of a concept to get through your head. These things appear in the host's network settings, just like physical NICs do, but you'll see that they're Microsoft devices. And they don't route directly to physical NICs, they go through the virtual switch, which then goes to our physical NICs. So in this configuration, I have 4 1 gig NICs, NICed teamed. I'm using the default team interface, and I'm connecting the virtual switch to that. And then I'm connecting my virtual machines to the switch like I normally would, and these new things, virtual NICs for the host, are connected to the virtual switch. And if I want, I can VLAN bind these, so I can isolate them on the physical network. And then, clever bit, I create QoS rules for each of these virtual NICs. So I can guarantee the management OS a certain amount of bandwidth for backup and RDP traffic and monitoring traffic. I can guarantee live migration 1 gig. I can guarantee the cluster maybe 100 meg or 200 meg, so that heartbeat always gets through. And that's your typical rack server you're using right now. Now the downside with that design is maybe these 2 NICs go to one switch, these 2 NICs go to another switch. If I lose a switch, I'm down to 2 gig of bandwidth. But at least I'm carving it up to guarantee certain amounts to the traffic. Maybe you'd actually put in another quad port card into that. What about iSCSI? Well, we can converge iSCSI NICs if we want as well. So all I've done is taken the last design and create 2 more virtual NICs here for iSCSI. Now the concern people have is iSCSI and NIC teaming are not supported together. However, the NIC team is below the virtual switch. So this iSCSI, or these 2 iSCSI NICs have no idea there's a NIC team down here. So we don't have that conflict. And actually, I can even do my MPIO stuff in the management OS with these 2 virtual NICs, just as if they were physical NICs. Downside for this on the iSCSI side here is my iSCSI traffic's coming down through the virtual switch, through the NIC team, through these NICs, and they're sharing these NICs and their associated physical switches with this other traffic. Some SAN vendors want iSCSI traffic physically isolated. Some don't give a damn. So you would have to check with your storage vendor to see if that would be a supported design. Alternatively, you take the first one I showed you, add 2 more physical NICs, and just do your iSCSI as you normally would with your 2 physical NICs. You see where I'm getting into this? There's a bazillion different options here. There's not necessarily right ones, but there are wrong ones.
Can you drop 1 more NIC to iSCSI?
Sorry?
Can you drop 1 more NIC to iSCSI?
There's already 2 there. So 2 is usually enough, but if you want 3, if your SAN supports it, sure. But there's 2 there. People normally put in 2 NICs for iSCSI.
Yeah, but can you dedicate, for example, for because
Why do you want to put a 3rd NIC in for iSCSI?
no, I was thinking even 4. So can you create like a virtual Microsoft switch, yes, or do the teaming on the Microsoft?
Potentially, yeah. But you'd have to check with your SAN vendor to see if that's supported. Here we've got a different design completely. So this is our traditional connect virtual machines to physical NICs. But over here I've got 2 NICs. And these are 10 gig in this design, and they support RDMA. RDMA, if we're using it, does not work with NIC teaming. The 2 are incompatible. So in this design, this has an IP address of its own, this has an IP address of its own. And if I'm connecting to a scale-out file server, they're on 2 different subnets. I explained yesterday that file server that its 2 front-facing NICs must be on 2 different subnets like an MPIO. So this will be on subnet B, that will be on subnet A. So it can communicate with those 2 NICs. And then we just have the normal Windows networking stack, and we create QoS rules on a per protocol basis. So I'll have QoS rule for SMB, I'll have another one for RDMA, I'll have RDP, monitoring, live migration, cluster heartbeat, backup, whatever else I think I need to put in there with a QoS rule to give it a certain amount of bandwidth. Here I'd probably enable jumbo frames, I can enable receive side scaling, so I can take advantage of SMB multi-channel on a per NIC basis. So that 10 gig NIC could have multiple parallel streams of SMB traffic. And that I could actually then span automatically across both of these NICs. So we can get some serious throughput on our SMB storage. So that's another design. The reality is I could keep going all day showing you different designs. There are certain roles. DVMQ is an offload for accelerating inbound traffic of virtual machines. It is completely incompatible with receive side scaling. So they must not be enabled and configured on the same NICs. In fact, they actually use the same circuitry on the NICs, but they are completely incompatible. One is for virtual machines, the other is physical server networking, like SMB traffic. So, nosebleeds, concussion-like symptoms. If you do, that's what's supposed to happen. It means you've been paying attention. There's a lot squashed in there, and my goal is to basically make you aware that you don't have to do networking the way you might have done it in the past, or the way you may have seen it in the past. There are lots more options. And it does take quite a lot of research to figure that stuff out for yourself if you're starting from scratch. I'm lucky because I deal with the product group directly, and I've learned quite a lot from guys like Charlie Wen, who would have PM'd the QoS side of things, and some of the other PMs who dealt with the networking. And I've trained a lot of partners over the last year as well, so if you're starting from scratch, find someone who knows this stuff already and consult with them.